If you do think you found some issues with the helper stuff, then talk to me after class, okay?
Yeah, I was going to come to office hours anyway to try to figure this out. I don't know if it's a problem with the helper, but like all of a sudden it just stopped working on my machine.
If it's consistently not working in the same way, that's probably not undefined behavior. If you're getting like, I literally just do 5 submits in a row, and half the time they're correct, half the time they're not, that's probably undefined behavior.
Well, it was like some has and now it's they're all full. And the more I submit, the worse the problem. And now it's consistent.
Oh wow!
And
okay.
Even if you're just you went back to a previous bit,
Yeah. So no idea.
Okay, we can take a look.
This is the strangest programming problem I've had.
Some operating systems are fine-tuned to make certain things faster than on other operating systems. So whereas I think I think OS X is, from a hardware perspective, the best, strongest automator, followed by Windows, followed by Linux. But like I sometimes see results that contradict that too, and I'm not entirely sure why. Maybe. Yes.
Yeah, that means that the operating system
Everything's an engine.
already, like you already know.
This is Twisted Mansion from Mario Kart 8.
I use 03 for the application, right?
Yes. You can try O2 though, if you want to. Okay, ladies and gentlemen, let's get to it. This is EECS 498, Game Engine Architecture. Jose brought up an interesting notice, that what makes an engine? What is an engine? Okay, you are developing an engine in C++ that eventually users will program on top of to make their games. But you are programming an engine that sits atop an operating system. An operating system developer had to program their layers so that you could program yours so that someone could program theirs. And below the operating system, you've got hardware programmers, right? And people developing the processors to make it all sing.
And at a higher level, wouldn't the languages also be engines themselves?
You could think about it that way, yeah. And so we find ourselves in a world where it's just layers of technology upon technology upon technology, and all of these layers have bugs. And so it's as if we have constructed a gigantic tower on top of a few floors that had missing pillars, okay? And let's hope the whole thing doesn't come tumbling down at some point. Anyway, it's a bit spooky to think about, but it's also very amazing that it all does work most of the time. Okay, anyway, and this is the moment when you can think to yourself, what if your compiler had a bug? I'm sure it does. And what if that bug was causing your code to not work on this assignment? How would you debug that? Don't bring that question to office hours, okay? I don't think I can help you with it so much. Anyway, let's go ahead and get to it. This is very likely to be a shorter than normal lecture. We'll begin office hours early if we have extra time. I want to show you a really cool engine to get started. This is UbiArt. This is, I said the other day that Bethesda was our favorite game studio. That's not true. In fact, Ubisoft is our favorite game studio. Okay, I hope they're doing well. And so this is a game engine that was made by Ubisoft to support their 2D teams. And in particular, it was driven forward, as far as I can tell, internally by the creator of Rayman, Michel Ancel. And it was originally used for the Rayman games. Now, when you watch... I want to show you the trailer, like the initial trailer for Rayman Origins. Yeah, watch this initial trailer for Rayman Origins, and I want you to pay attention to the art, how it moves, okay? How smooth it all is. Let's take a look. This is Rayman Origins, their initial E3 trailer.
Peggy 7.
Okay, so this game's art style, particularly at the time, was considered to be extremely smooth 2D, okay? Whereas a lot of 2D is kind of sprite-based. This 2D is kind of an animated vector-based style. In fact, if you look at this, you could have sworn this game was made in a legendary software called Adobe Flash, okay? Has anyone heard of Flash before? I grew up in the era of Newgrounds.com, Albino Black Sheep, Next Gen Studios, if you remember any of that stuff, and all the fun memes you could go and enjoy in your school's computer lab. It was a legendary tool that basically allowed you to create really great high-resolution vector graphics. When I say high resolution, I mean this is art that you can infinitely zoom in on, okay? And because it is not bitmaps, it is vector art. I don't know if this is vector art, but it is definitely in that style. Super high res, lots of squash and stretch. You've got pieces of characters that are animated relative to other pieces. This is sometimes called skeletal 2D animation. And this, you can just tell this is an engine that focuses on the artist. First and foremost, it is completely and utterly concerned with what the artist, the 2D artist, needs to do their job. Initially released in 2011, it was famous for Rayman, but some other cartoony games like Gravity Falls. Has anyone watched that TV show? Right, so this is kind of the perfect engine for a Gravity Falls game. Let's take a quick look. This is for the DS.
Gravity Falls.
Like you've never seen it before. Right now, play as different as you uncover an all new mystery.
Right, so as you look at this, this is lower budget, of course, and it is on the DS, so lower resolution, but it's using the same engine. It has some of the same vibe. Child of Light is another kind of different art style, but it uses this engine as well. Different feel for sure. It wouldn't be an Ubisoft game without crafting. So we have an engine here that can do a large variety of art styles. And I want to show you a trailer for UbiArt. Let's take a look at that, how it works under the hood. Right? So you can see it's all integrated. The artist can get into the engine, use the tools to draw a character quickly, give them bones quickly, separate the pieces, and then create a quick animation without having to involve a ton of engineers, okay, or deal with a ton of different external tools. And that can be extremely powerful, okay? Extremely so. A quick video demonstration from GDC, and then we'll move on.
I'm ready to see. Yeah, ready to see. Look at it right now. We're going to do some stuff. Julian's going to play around. And basically, he's walking around. This is the game, right? Well, I mean, actually, it's the editor at the same time. So he's playing. Oh, wow. You can edit on the fly. That's crazy. It's really crazy editor. So, I mean, okay, Julian, we don't like these guys, dude. They're in the way, baby. Just stand for a sec. No. They're kind of. Oh wait, oh, I'm sorry, I did it. Wow, that's dirty. That's dirty. So this is the engine. This is the game running in the engine. That's a level that you have. Now I'm just gonna hide the art layer for a second.
Oh, okay. Yeah.
This is what a level designer sees every his life on Red Dead Legend. Okay, this is all you get. So we're looking around. There's this collision. There's some gameplay elements and the characters. Right. Now, what's interesting to note is the gameplay collision is actually pretty beautiful already. It looks like what it's supposed to be. It's got grass, it's got rocky surfaces and everything. Now watch this. This is pretty cool. I like this. So we've got a grassy surface on top, right? Okay. Simple. But what if we make a 90-degree angle? If it's grass all along, it's going to look weird.
Gotcha.
We make a 90-degree angle, and now our engine is
Okay.
That's basically how it works. And he's playing while editing. I mean, we don't necessarily do this as designers because we're always easy, like one-on-one.
Gotcha.
It's just the flexibility that I can be jumping in and I can be working on it in the game itself.
I feel like a company capable of making these kind of tools should not be going bankrupt right now. Okay, so super cool stuff, right? It was used to create some extremely impressive games. Maybe this is a hint as to what they're failing at, but the games didn't sell very well, unfortunately. So those of us who played it and enjoy this kind of stuff really did enjoy it. But anyway, right? Designed first, second, and third to support 2D artists, okay? And you can compare this to Unity and Unreal, where art and animation, right, kind of fall outside the engine, okay? And if it is done in the engine, it really caters to 3D aesthetics and not 2D. Unfortunately, this engine, as super cool as it was never open sourced or publicly available. And you have to wonder whether it might have been worth their time, right? The amount of indies who are looking for good 2D engines, the amount of people who just like go to sleep dreaming about the good old days of Flash, okay? They're out there, and you wonder if it maybe is a bigger market than one expects. But in any case, we will talk about Adobe Flash in the near future. Okay, so I'm not going to show you this link. You can go watch it if you want. Okay, but anyway, UbiArt, we'll remember you fondly if they don't make it through this. So we'll see. All right. So some announcements. Blah 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 blah. Yes. So Homework 7 is coming up. Actually, crunching hard when you return. No, that's an announcement for last year. I don't really have any announcements. Does anyone have any announcements? Anything they want to show off? What is Wolverine Soft up to? Who's in Wolverine Soft? Yeah, what's Wolverine Soft doing?
We're going to mini jam next week.
There's a mini jam next week. Okay, that's your announcement. You don't get any extra credit for going. Okay, this isn't 494. But you should consider it if you want to make a game quickly. No better way to improve your appreciation of engines than to go out and use them to do cool things, such as make a game. And to do so quickly is even better. Okay? One thing I want to do is, like with the other quizzes, I want to kind of go through and show off some of the questions, and also I want to talk about them. Okay? Let me see really quickly here. So what questions, does anyone have any questions that were like really hard or interesting or you were curious about? Any questions? Okay. I don't want to put all these questions on recording like I just did like a third of them. Okay. So let me see really quickly. Oh, I can't. I'm recording right now and streaming to Twitch. How do we do this? Is there a freeze? Can I stop recording? Oh, wait a second. Here we go. All right. Now I just wait. Hold on. Now I have to do this to you. Sorry. Okay. So I will bring up the questions that I want to talk about. So what do we want to talk about here? No, that's not interesting enough. I like this one. This one's pretty cool. So this question was a question about the 2D affine transformation matrix. Okay. Remember, the transformation matrix is a extremely fundamental and important matrix. If you're going to memorize any matrices, this is probably the one to do it. And it's capable of embedding translation operations, scale operations. Now, those two are pretty easy to notice. And then rotation, which is a bit of a nightmare, okay, if you're even slightly crusty on your trig, which most people are. So the question here is, looking at this transformation matrix, can you tell what kind of operations are embedded within it? Right away, the question is made much easier because you know that the only things that are going to affect a 2D transformation matrix over here in these cells is translation. Okay, these will move whatever coordinate you feed in by x and by y. Okay, so you know that translation is going to be a part of the answer here, which helps you narrow everything down quite a bit. Now, you might be thinking, well, you know what, actually, usually the transformation matrix, if there's no scale, is the identity matrix. So 1, 1, 1. We've got 0 and 0 here, so you might think that we are transforming our scale down to 0. And it's possible we're doing that, but not the case, okay? Not the case, because if we have a scale operation here, then what is going on in these two cells right here? Well, these two cells are affected by only rotation, okay? So you know rotation is also a part. Translation is a part of this, rotation is a part of this, and there is no translation, rotation, and scale option, okay? And so I'd go back and check, but I'm fairly certain this is not a scale going on. Yeah, so.
In the case that rotation does set the two scale
yep.
adjacent ones to 0 by just being 0, then it multiplies the scale
yep.
by 0. How does it not set scale to 0?
How do you not set scale to 0? I think so. There's a certain order, and off the top of my head I've forgotten. There's a certain order you're supposed to do things in that allows you to get translation, rotation, and scale at the same time. I'm not entirely sure how the math ends up working out, but I do think that's important because you don't want to zero out your scale. Okay. All right. So, what else? Let's see here. Going back to, sorry, stream. Bye-bye. Okay, let's see here. What other ones were interesting to a lot of people? Let's see. Okay. This one is a good one right here. So this question is a nice little convenience function. It is inside of your ImageDB class, if you have one. And it is, you might expect it's a static function, a public static function, because it's basically a utility class. You provide the name of an image, and this function will get you that image, and it will get you that image in the form of a STL texture pointer, okay? Now, if you're doing your homework 5 or your homework 6, then you will run into the question of caching, okay? Because I believe you'll start to fail test cases for performance reasons if you're not caching your stuff. This function works out, okay? It loads things in, okay? It creates a STL texture, but what it doesn't do is it doesn't cache this texture. Every time you use this function to grab an image or reference to an image, you are going to be loading from disk using img load texture, and that is not really a good idea, okay? In here, you might have a dictionary of string to STL texture pointer, okay? And it wouldn't be a dictionary, that's C#. In C++, it would be an unordered map, probably, of string to STL texture pointer. And that is what you'd want to do here. So the biggest concern here is definitely performance. And on homework 5, if you're not doing this, there's a decent chance you're not getting very far, okay? What else in the quiz might be of interest or a bit trickier? There were a couple of tricky ones. Nothing too crazy, but this one right here was kind of fun. And I saw some of you drawing this out in Microsoft Paint, which was very funny. I love to walk around while you're doing the quiz and kind of like, okay, what are they gonna click on? What checkbox are they gonna click on? How are they solving this? This is the one where basically it's about the AABB algorithm, and this kind of asks you to remember how it works. So here we have two SDL recs, okay? And if you draw this out, you'll find that indeed the two rectangles are kind of side by side, a little bit ajar, but they are definitely not overlapping each other. They're not colliding. The thing, though, is that on the y-axis, they are overlapping. If you project the two objects on the y-axis, they are overlapping. If you project them onto the x-axis, they're definitely not. And so you will have a small performance gain if you check the horizontal axes first, because you'll immediately be able to say, no, they're not overlapping, thus we don't need to check the other axis, okay? And so that's kind of how you can reason about that one. Okay, so let's keep going here. Okay, anything interesting? What else we got? Yeah, I don't think so. Yeah, nothing else I don't think is particularly interesting. If you have a question you really wanted help on the quiz, please let me know, okay? Ping me, DM me, or you can ask during office hours tonight. That would be a great idea. And we will get you back into it, okay? Okay. All right, so that is the quiz number 3. What I'd like to do is I'd like to finish up our talk on components. You are in the middle of homework 6. You're optimizing stuff right now. And I would like to try and get you the fastest head start as possible on homework 7 when we get to Monday and it flips over to that, okay? Get a fast start on homework 7, and you can enjoy that spring break without having to care at all about EECS 498, okay? So if you remember, components, composition as a means of reusing our code is something that is meant to save us from the problems that inheritance hierarchies run into, okay? These are fundamental problems with the ISA approach to categorization, okay? You remember how the panda, the ice panda, the Lovecraftian panda were very easy to create a reuse structure for, but as soon as we got to something as simple as an ice snake, everything fell apart. And the only way we could have the ice snake in this inheritance hierarchy was by violating our dry principle and putting ice at 2 different locations, which is not really what we want, okay? And so the question is there a better approach? Multiple inheritance is definitely not it, okay? right? But we want to have the traits of multiple other things. In other words, we want to be defined not by who we are, but what we can do, okay? And you remember that famous phrase, if you're ever confused about what composition is all about and why it wins, you remember that famous phrase? If it sounds like a duck, if it walks like a duck, if it looks like a duck, it's a duck, okay? And that will give you everything you need to know about why components are so magical and why engines like Unity and Unreal tend to use them, okay? Composition, it is a has-a relationship rather than an is-a relationship, okay? A duck is a bird, okay? A duck is a bird, but in the realm of has-a relationships, you say, no, a duck has feathers. A duck has the ability to float. A duck can quack, okay? And that's how you describe them instead. We always have these kinds of classes when we go to make components, okay? We have a class like an actor or a game object or an entity, as it's called here, that is nothing more than a container for components, okay? This is your panda. This is your snake. This is your whatever, okay? You then have a component parent base class that has a bunch of lifecycle functions inside of it. Lifecycle functions like start, update, destroy, end, okay? And these, you can think of them as adjectives in a sense, okay? These components are your iciness, or your has fire effect, or your render component, okay? In Scribblenauts, you remember Scribblenauts from last time, right? The component system is how adjectives are implemented, okay? Once you create one adjective, like flying, okay? Every object you put that on will automatically have its component added onto it, and that component will have wings spawn, okay? Whatever the object's bounds is, however big or small the object, it will take the wings and put it right onto the object. Done, okay? That is how it's going to work. One of the magical things about components is what you see here. When you read this code, it is not describing any particular enemy or actor, okay? It's simply describing an effect that can be added to anything, from a character to an enemy to a floating chunk of platform, okay? And so, what does this component do? Okay, if you are experienced with C# and Unity, you might be able to guess. Okay, this is a component called sine wave movement. It notices the initial position. It notices it grabs your transform component that contains your position, your rotation, your scale. And then over time, it puts you on the sine wave as time progresses, and so you go up and down. Okay, this can be added to an enemy, but this could also be added to a chunk of platform, okay, like this, right? Suddenly, with this reuse, you can create a flying turret enemy, or you can create a floating platform. And both of these are things you tend to find, for instance, in an action shmup game, okay? That's the magic of components. You're not describing any particular thing, you're describing an aspect or adjective of that thing. You can then use it on anything you want. So, when it comes to building all these characters that we tried to last time, with inheritance, this was hard, okay? But with composition, here's how we would approach it. A panda, what makes a panda a panda? Any thoughts? Yes?
Kung Fu.
Kung Fu, martial arts. Absolutely. I should probably add that. Everyone's going to laugh at that in future semesters. Maybe I will. What else? Yes?
Vegetarian.
Vegetarian. Okay, I think, no, I have carnivore first. Okay, so here are some components. Fur, right? A panda has fur, so we're going to give it a fur component. And maybe this is a component that renders our character in kind of a fuzzy way. It makes it a bit blurry, makes it look like it has fur. Okay? But it also, pandas do eat meat. Okay? So pandas, very cute. Okay? Sometimes cuddly, I imagine. Be careful around them, they will eat you. Okay? So they are carnivores. They get the carnivore component. Now, a panda is also a living thing, and so we need some component that's just going to store a bunch of floats and maybe some booleans and strings. So, for instance, floats related to, do I need to use the restroom? How's my hygiene? What is my hunger level? Okay? There are other ones, though. It needs to have a render component because we need something to draw this panda. We don't want it to go invisible, right? Now, this panda, it eats meat, so it gets the carnivore component, but no one would call a panda a carnivore, right? What do they call pandas? An omnivore. Is there a component dedicated to being an omnivore? No. You achieve the omnivore effect by combining a carnivore and a herbivore component. Okay? These components would be responsible for identifying what can I eat in my environment. So if you have both of them, you can get the effects of both. Okay? So you can create a panda out of all of these different components, and you can reuse them across objects. So if you want to create an ice panda, you take all these components from the normal panda, and what do? You simply add an ice skin component. This ice skin component would basically take your mesh or your render and make sure that a different shader is used when it is finally rendered. This is literally all this really is, okay? Look at this panda. All it has is a blue texture that's kind of overlaid onto it. That's it, okay? A shiny blue texture. That's it. Now it's icy. Great. Wonderful. Okay? If you want to make a Lovecraftian panda, you might add a zombie skin component similar to the ice skin component, okay? That might be a problem for us later. And a flying component, okay? If you were to make a bird character in the future, you might be able to use that flying component to finish the bird extremely easily, okay? For the snake, we need to add a scales component, a poisonous component, and that ice skin component that we used on the panda, the ice panda earlier, can be reused here, okay, to complete things much faster. Okay? Compare the approach on the left, the HAZA, the composition-based approach, to the approach on the right, the IZA approach, okay? In my opinion, one of these is a little bit more flexible, a little bit more fun, and a little bit more straightforward than the others, all right? So the old questions of where does the ice snake go and what happens if the ice panda melts? How can you take an ice panda, if you have a component-based approach, and turn it into a normal panda? Anyone know?
You just remove the ice skin component.
Yeah, at runtime, you can write some code that just gets rid of the ice skin component. That's it. It's not that hard. This is not something that you can typically do at runtime with an inheritance-focused approach, okay? Some bonuses. If you want to make a scaly panda, it sounds like a really creepy panda. If you want to make a scaly reptilian panda, what do? Well, you can just reuse the scales component that you built for the snake. If you wrote the component in a very flexible way, it should just work, okay? How do you make a flying zombie snake? Well, you already have a zombie skin component and a flying component from the Lovecraftian panda. And so you slap that onto the snake object, and suddenly it has wings, and its skin looks all creepy. Okay? And that's how it goes. Notice what has happened here. Over time, as you develop new components, they form an ever-expanding toolbox. And the possible combination of those components, okay, go exponential. And so, the amount of surprising creative things you can make goes exponential as your toolbox of high-quality components increases, okay? What's even more, you know the cool thing about components? Imagine if your game team has non-technical team members, like a game designer. On The Sims 4, we had a bunch of engineers, but we had even more game designers. And they generally didn't do any programming. They didn't really have programming skills. But they were still able to make things, okay? Because we had a lot of great technology, a lot of great components that they could slap together and see what happened. When they needed new features, they would come to us engineers and we would make them. Okay? When they found bugs, they would report them, and then we would fix them. But they were allowed to work without taking time from us. Okay? Which was really, really useful. Very productive. Okay? By the way, did you spot the big issue with this approach? Okay? I kind of cheated. Remember when I was so gung-ho about keeping dry in the ISA hierarchy? Well, we violated dry in here, didn't we? With ice skin and zombie skin, right? These are clearly reusing skin-based logic and data, okay? Isn't this violating dry? It is. It's a problem. But how can we solve it? And this is the plot twist, the 11th hour shocking reveal, is that composition and inheritance are not necessarily rivals. They are complementary, okay? Because in this case, we use inheritance to fix and get dry back with our components, okay? And so you can find yourself running into dry issues with inheritance, and you use composition to fix those problems. And then you start running into composition problems, dry problems with composition, and you fix those problems using inheritance, okay? So it's important, it is super useful that you have both of these topics and techniques in your toolbox, okay? So, and this is how we would deal with this. We would create a component called skin, and we wouldn't use the skin component, okay? But we would derive from the skin component. We would store our common skin-related logic in that skin component, inherit it into zombie skin and ice skin, and then we're good to go. We're back to dry, all right? So, pretty good time. Composition is a fairly well-known design pattern, and it has been known for a long time. It is a feature of the famous Gang of Four design patterns book, and in that, they explicitly say that they tend to favor it over inheritance-based approaches in most situations, okay? Favor object composition over class inheritance. It's a bit interesting that we don't tend to learn it in a lot of our courses, but it is a very powerful way to program and reuse logic and data and code and assets, especially in creative industries where you want to be mixing and matching to find new, interesting ideas faster, okay? So, a industry example for you, the Sims franchise has a lot of objects. Okay, it has slip and slides, it has stereos, it has grills, it has chairs, it has TVs, okay? When you have a stereo and you would like Sims to be able to listen to it, you might write a component. What might you call that component? Any ideas? Let's write a component for that stereo that allows users to listen to it. And while they're listening, they're standing around and their stats are going up. Their motives are improving. What do we call this component?
Plays music.
Plays music, yeah. I would probably call it can listen to, right? And so you create this component for the stereo, and now the stereo is working. Sims can walk around and listen to the stereo and have a good time. But what else could we use this can listen to component on? What kind of objects can a human being listen to? Any ideas? Household objects. Things in your yard, things in your living room. What do you got? Come on.
These?
AirPods. A VR headset. A TV. A computer. So you create that component once, and suddenly you can bring it to any objects for which it makes sense. And you can have an object, or an actor, as we call them, with many components, because you can do many things. A TV is something you can listen to, but it's also something you can watch. Okay, a computer is something you can listen to, but you can watch it also, and you can also play on it and interact with it. Okay? And so it's a very, very flexible approach. One of my jobs at The Sims was to create a waiting line component. A super, super fun component to work on. This is not the first waiting line systems in the entire series, because eventually The Sims 3 had one, I think in one of their DLCs. But The Sims, normally in The Sims games, if you tell two sims to walk toward one object at the same time, only the sim who reaches the object first will get to interact with it. The other sim, the interaction you gave them, will get canceled, and the sim will be bored, frustrated, and then walk away. Okay? And so that's not great for all kinds of interactions. So I created a waiting line component that you could pop it onto an object, and if the sim walked up and someone was already using the object, that component would basically define where does the waiting line start. Okay? And so the sim would see, oh, someone else is using it, let me go ahead and wait in line. And a line would start to form. Okay? The component would also allow you to configure how wavy was the line and in which direction would the line go out of. One of my favorite bugs on this is that, you think, oh, this is great, right? We're going to calculate the next position. Oh, there are 3 sims in line, so we need to calculate this further position out from the object. Well, what happens if you have an object? If you have an object and you've got this line of sims building up, so there's a sim here, and then behind them there's a sim here, and then behind them there's a sim here, where does the next sim go to stand in their waiting line? The most reasonable approach would be to have the line start to bend around this wall, right? Probably. Head out this way. But that's not what happened. What happened instead is that the next sim would be like this. And if the wall was really high, you'd have a sim literally looking into the wall. Just totally fine with it all, right? They were looking like they were getting punished. Okay? And then, as soon as the line moved up, the sims would step forward, and then when it was my turn to step forward, the sim would go all the way around the wall, right? Right? It was ridiculous. Completely so. And so what we started to do was we said, okay, we can't just calculate where we need to be, where this line is going to go mathematically. We need to actually do some ray casting, some line tracing if you're used to Unreal, to make sure that there's nothing impeding our line. And if there is, the line needs to organically curve in a different direction. And that's what happened, okay? In any case, it makes certain scenes look super dynamic, especially as you have sims that are kind of moving forward and adjusting. You could put this component on anything, so it makes a ton of sense. It was designed initially for a restroom object, but I slapped it on like a TV once. So I would send like 10 sims rushing over to like start watching the TV, and I would put the waiting line component on the TV. And so the first sim that would get there would turn the TV on and go sit on the couch and like relax. And every sim, like 9 sims to reach the TV, would just be like watching him while standing in a line, waiting for their turn to watch. Okay, it was a little bit buggy, it seems, but very funny. You could put that on anything. One of my favorite cheat codes that one of my colleagues wrote was a set as head cheat code, where you could take any object and make it a sim's head. And so, like, that sounds kind of funny, right? Kind of goofy, but it gets kind of existential when you say, I'm going to take 2 sims, I'm going to make their heads televisions, and I'm going to ask them to watch each other. It got very artistic, okay? Could put that in a museum, maybe. And another thing that's really fun is that, well, wait, you can set anything as the sim's head? Anything? What about a chair? Well, I'm not even going to say it. But what about a chair? So you could have a chair set as a sim's head, tell another sim to sit in that chair, and they would go up onto the sim's head, and you could have that sitting sim have a chair as a head, and you could have this kind of stack of sims sitting on each other and have them all walking around and create kind of an abomination right there in the game. Anyway, I'm not sure why I'm telling this to you, but the amount of fun things that can happen when you start getting creative with your programming, when you adopt a flexible composition-based approach, like, who knows what can happen, okay? But of course, that's the point, okay? It's meant to be very nice and creative. So a question then that's really, really relevant to this course, usually I just kind of blow by this section, but it's worth talking about a bit more today, is how do we get composition? Well, if you're using something like Unity, an engine that already exists, well, you're going to get composition by default, okay? This is the easiest way to start programming with components and getting a feel for them and their power, okay? In Unity, when you click on an actor, when you click on a game object, as they're known in Unity, you will, on the right side of your screen, see all of the components that make that actor tick, okay? You can remove all of these components except for the transform, and you will have just an empty, vanilla, invisible game object that can't collide with anything, doesn't do anything, whatever. The important part to realize is that a game object is nothing more than the sum of its components, okay? There's nothing special about one game object versus another. If they have the same components, they are the same, okay? In Unreal Engine, same idea, okay? Same exact idea, except that Unreal really, really loves to have very large components, like the static mesh component, that is a combination rigid body, render, collider. It'll do your homework too, okay? It's very big, very chunky, whereas Unity really loves to have a ton of different components that are small and focused and do all those different things, okay? This UI is kind of nasty. What it's saying is there's an actor called light switch, and it has two components, static mesh component and aft toggle actors. This line right here, I believe, suggests that you wrote this one. Okay, you added this one. This static mesh component is actually required by this object type based on its location in the inheritance tree. It's a bit annoying. It's a bit funky. It's a bit messy, but Unreal is worth it. Okay, it simply is. All right, so if you happen to be an EECS 498-007 Game Engine Architecture Upper Level CS, okay, then you will be making your own component-based system. It's my favorite part of the course. It was my favorite part of writing the staff engine, okay? And it is what is going to allow you to move from our top-down 2D adventure game genre that we've been in for weeks to something that is much, much different. Suddenly, we get to choose what genre we're going to be in because we get to write the rules, okay? And so that's how it's going to be, right? The way that you'll do this, as we talked about last time, is that you're still going to have a JSON file in a scene file that is basically JSON objects representing actors. The actors will have a name, but now the actors will have a components object inside of them. And this object will have a bunch of miniature objects keyed, okay, on an ID that are themselves different components, okay? And so, right, those components are Lua scripts. The variables get plugged in to those Lua scripts to change how they'll run, what their starting state is. And your responsibility is going to be to call the right functions on those components at the right time to make them work, okay? So if you want to build your own, and this is something you're probably going to do, okay? Actually, in this course, you're going to build your engine such that you can have Lua-based components, but you can also have C++ components, and you can have all of this in the same project. In fact, C++ components can talk to Lua components, and Lua components can talk to C++ components. It is a bit of a trick to make that work. In any case, you have a default component data type, okay? And you have a bunch of public lifecycle functions, things like start, update, destroy, okay? These are functions that the engine will call at the right moment automatically, okay? As the user of the engine, you just create the functions and you get to assume they'll be called, okay? You put cool gameplay logic in and the engine takes care of calling it at the right time. So you've got a component here, but what we do to create interesting components is we have to derive from that base component class. So we have our transform, for instance, and that transform is going to be a component. So it will have these functions like start, update, and destroy, but it's also going to add some additional stuff in. A transform is responsible for keeping track of our position. So for instance, it might have some sort of 3D point data type, okay? Basically a vector 3. And it also might introduce some other functions, okay, to help us interact with its unique data. So for instance, set position, which allows us to change that position or get the position, okay? So pretty simple stuff, okay? If you actually were writing your own transform component, you would also have rotation in here. You would also have scale in here, okay, as you learned from the matrix. We would also have an entity class of some sort. This is just another name for an actor or a game object class, okay? And if you look at it, it really just is a container. It's just a wrapper, a container of components, okay? These components get created, their pointers get shoved into this vector struct, or this vector data structure. And when we update our game 60 times per second, we run through every component that we know about, and we update all of them. We call the update function on that component so that it can do whatever it needs to do to update itself, okay? We might have other functions that allow us to mess with components in different ways. For instance, add component, which is going to return a pointer to the component base class, okay? So actually, I think this should be T star, looking at this code right now, because this is a component. This is, if we're templating on class type T, so we're creating a new T, yeah, I feel like we should be returning T star, not component star. Anyway, so we create a new component of the type that we specify in our little template argument. We then push it into our components array, our vector. We then call start on that new component so that its start lifecycle function can run. Okay? And then we return that pointer so that the code that added this component can do things with it, like customize the component, change things. Okay? In a main function, testing this out, you can kind of see how it works. We create a new game object, we create a new actor, we add the render and the transform component to that actor. Okay? We can get that transform back and we can mess with it, like change its position if we want to. If we print out the position of that component, then we can see that it did indeed change, and we can run all of the component's updates right here by calling entity.update, which will go through each component, call update on each component, and boom. Okay, that's it. It's really not that much code. It's really not. And it's not that complex of a setup. So what you'll find is that I think homework 7 feels the most EECS 482 of any homework in the entire course. And I feel like now everyone's like, oh no, right? It's not quite that hard, okay? But it is the kind of assignment in which you need to think very carefully about how you're structuring your code and about how you're going to get these calls done at the right moment, at the right time, okay? And if you do that, you're not going to write all that much code, but the code you write, you're going to have to think about a little bit, okay? All right, so a summary for you, okay? Composition is a flexible alternative to inheritance, but you might as well think about it as a complement, another big tool for your toolbox. It allows you to mix and match functionality onto different objects at runtime, and it's very convenient in doing so. It is super great. It's almost a perfect fit for any scenario or situation that involves describing an object by its properties or adjectives or something like that. Okay? It's really, really good at allowing experimentation because it allows non-technical team members to create new things by mixing and matching what already exists without having to write any new code or understand that code. It can work really well with inheritance. So often you'll have a bunch of similar components and you'll be able to reuse logic between those components by having a base component class. Okay? And that is basically all I have to say on the topic. Okay, so question, does anyone have any comments or questions on inheritance, versus composition? All the 494 students are like, Austin, like I already know all this, okay? But we got lots of people who didn't take 494, right? Yes?
How did like on functions work? Like the ones that aren't update we can call, like on trigger enter.
Yeah, so on trigger enter, you should look at the exam from last year because I can guarantee you pretty much that one of the questions on your exam will be, here's a bunch of C++ code. Here's some Lua scripts. Write a new lifecycle function to make our users happy, right? So on the exam we did last year, you had to write and power up and make it work a lifecycle function called onBecameVisible and onBecameInvisible, okay? And so you had to kind of keep track of where is the object. Is the object in the camera view? This is the first frame. It was hidden and outside the camera view. Now this is the first frame. It is visible. So call the function on the Lua object, right? Anyway, how do these functions like onTriggerEnter work? Usually you have some sort of global system written in C# or C++ that's kind of keeping track of where everything is. Where are all the colliders at? And when it detects that, oh, this frame, we just found out that 2 colliders are overlapping, I'm going to resolve those colliders and push them out maybe. But I'm also going to go to both of those actors. I'm going to go to all of their components that I know have onCollisionEnter, and I'm going to call all of those functions right now. And I'm going to send in a struct that tells my Lua scripts what you ran into. So, right, you are truly going beneath the surface of Unity now. Those game engines you love, you're going to find out how they were implemented because you'll have to implement them yourself. Okay, it's not as bad as it sounds. Start is kind of particularly easy, I think. Like all the homeworks in this course, it's going to kind of take things slowly, one feature at a time, right? And you'll make things kind of more deep and complex as you go. So don't worry too much. Okay, any other questions? Anyone? Okay, good. Very good, very good. Well, we've got about 30 minutes left, and this being still a very new course, I wonder what would be a good number for this course when it gets made permanent in a couple years? When it's finished and gets made permanent.
What numbers are open?
455?
Oh, is it 95?
495 exists. It's software for access. It's a capstone course. Yeah. 420? That'd be really funny. I should probably ask for it. 469? I have been thinking about making a new passive multiplayer networking course, a live ops course, because back-end servers and multiplayer is so important these days, right? I mean, people ask me how I made this, and that's like my hint that, oh, we got to have a course, okay? I hope they'll give me EECS 404.
I was going to suggest 404 for this one.
That would be sick. No, this is not a multiplayer or network-focused course, so it wouldn't be a good fit here. But anyway, so we'll have to see. If you've got any good ideas, let me know. I do kind of like 420. I wonder, I better wait until I get my next contract before I ask for that one. But we'll see. Yes?
What's a common linker issue number? Because we could honestly make the class.
Linker issue number? That's too obscure. People aren't going to laugh at that.
Well, they're not going to laugh at it initially.
Yeah. Okay, so what I'd like to do is I would like to start off, so I was early, but I want to give you a taste of Lua. Okay, I've been talking about Lua. I keep mentioning it. The idea of learning a new programming language, especially a legendary one like Lua, was super exciting to me. It's part of the reason I wanted to make this course a couple years ago. And I've got a video, 100 seconds, from a YouTube channel that's very popular these days called Fireship. Okay? I'd like to watch it with you. Okay? And let's see here. So the amount of Lua you will need to learn is not the entire language and not super deep, okay? But you will want to get a feel for how it works and how a Lua component works in particular, so that you can understand what the test cases are doing and possibly even write your own. You will not be able to write games or content for your engine if you do not learn at least a bit of Lua, okay? And so you will eventually want to do that. There will be Lua questions on the exam. You'll have to write some Lua code. That's a guarantee, okay? And so let's go ahead and learn a little bit about Lua.
Lua, a fast multi-paradigm scripting language famous for being so underrated. Imagine a language that's easier to learn than Python, while also being faster and more portable than Python. Lua was named after the moon. When it was designed by a team of computer scientists in Brazil in 1993, it's lightweight and extremely fast because its virtual machine maps very closely to C, and when used with its just-in-time compiler, it's widely considered the fastest scripting language in the world. This makes it ideal for embedding into other applications, like World of Warcraft or Roblox, for example, or users can write Lua to build their own games and features because the language is embedded into the base game. It's easy to learn because it has only 21 reserved words and has only one data structuring mechanism called a table that can represent arrays, dictionaries, graphs, trees, and more. It also supports collaborative multitasking with coroutines. Its standard library is very minimal, but it does have a large ecosystem of packages with the Lua package manager. To get started, install it, then create a file ending.lua. Declare a variable by providing a name and value. By default, variables are global, but make them local with the local keyword. It's a dynamic language, so no type annotations are required. We can then use print to output the value to the standard output. There are no classes in Lua, but anything you can imagine can be done with functions and tables. A function is declared with the function keyword, then closed with the end keyword. Functions are first-class objects, which means they can be passed around to other functions to support functional programming patterns. Now, to structure data, you create tables with braces. A table is actually an associative array, which means the index in the array can be replaced with different values. By default, it uses integer values, and the craziest thing about this language is that it starts the index at 1 instead of 0 like most languages. That gives us a conventional array, but we can also easily create a dictionary by giving the keys a string value. Now we can use for to loop over every key value pair in the table. The language is single-threaded, but we can use coroutines to pause and resume a function. Create a coroutine, then use yield to suspend its execution. Now somewhere else in the code, use coroutine resume to continue execution until you get to the return state. Now, if you're a C programmer, you'll be happy to know that Lua has a very simple C API. It allows us to run Lua code inside a C program, or vice versa, run C code from a Lua program. Now, to execute your code, open up the terminal and run the Lua interpreter. This is in Lua in 100 seconds. Hit the like button and subscribe if you want to see more short videos like this. Thanks for watching, and I will see you in the next one.
Okay. All right, Lua is absolutely famous for its portability and its simplicity. It is so simple sometimes that it actually kind of makes things a bit harder. And Lua, I will say, it is beloved for many good reasons, but it is also the biggest footgun language I think I've ever seen. Well, not C, or sorry, C++ level footguns, but it loves to do little things that are a bit opposite of what the industry went with. So for instance, when you write a variable in a function in C++ and in almost every other language, that's what we call a local variable, right? That variable is defined in the function, and thus its scope maximally is the function. You go outside the function and the variable no longer exists. That's the opposite of how Lua works. Notice that in Lua, you have to write local, okay? If you want a local variable, you have to write local. And if you forget to do this, that is a global variable, okay? And that can really mess things up. Anyway, there's some other interesting footguns that will probably get you a few times, okay? And you can look forward to discovering those. We'll talk about those more when the assignment really begins next week, okay? Does anyone have any questions or comments on anything in the course, anything with Lua? On homework 7, you will not be using the raw basic Lua C API. You'll be using a pretty well-known library called Lua Bridge, which makes it even easier to integrate Lua into any C++ project, to make function calls between C++ and Lua, and stuff like that, okay? So I hope you look forward to it. It's going to be really fun. How many of you, and you don't have to raise your hand if you don't want to, how many of you are basically finished with homework 6? Okay? It's way better than last year. Way better. Okay? You don't know how good you have it. All right? But I know this is a very hard course, and I hope you've had a chance to take a little bit of a rest. And if not, homework 7 and that nice spring break is only about a week away. Okay? Only about a week away. So keep fighting the good fight. Do what you can. If you're a bit behind, do your best to get caught up, and use office hours to help you do that. Okay? All right. I will see you all next week, Monday. All right? Take care, all. Bye-bye. Office hours starts now. Yeah. Okay. Just a bit. Yep. I'll be over there. Okay. All right. Hey, everyone watching online. I will see you later. Take care. Bye-bye.